To demo something that I promised in my last video where I talked about writing a JDBC driver for Coherence. Um, some of my videos that if you have watched doesn't necessarily recommend you do certain things with Coherence. Uh, these are all exploratory videos where it tells you that what's possible with Coherence. Coherence is a jar file and you can make it the way you want it. One concept that I wanted to show case was the concept of data sharding. It's a very typical database concept, and I wanted to achieve that using Oracle Coherence. So this is a very simple JUnit test. What I'm doing here is I'm creating two caches, shard1 and shard2. Uh, these are the names of the caches. And I'm putting 100 entries in shard1 and 200 entries in shard2. So let me just to be sure that I start from afresh. Um what I'll do is I'll start two storage nodes, one by name shard1. So let me start this. And while this is coming up, I will start shard2. So now you have two storage nodes. They have the same clustering information. So same cluster name, same WKA and all that. So they're part of the same cluster, and I'll show you using the JConsole. And then once they're up, that they are, I will run this test sharding and execute this program. And once it's done, I'll show you what data sharding I'm talking about. So it's done, and if I open my JConsole, I can pick, let's say, any of the two default cache servers. It's part of the same cluster, so it doesn't really matter. I have settings that it actually can, they're all remotely monitorable. So let me start a default cache, connect to a default cache server, go to MVs and go to cache MV. And here you see two services, shard1 distributed and shard2 distributed services. If you open it, this cache service starts initialize shard1 cache, and this one shard2. But the difference is now. Shard1 is only initialized on node 1 and shard2 is only initialized on node 2. And just to tell that I'm not lying, this cache has all the 100 entries ending up on node 1, and node 2 all the 200 entries ending up on node 2. So now there may be rare use cases, I'm not discounting that it's not valid, that you want to achieve something like this. You need to look at, but before you actually go this route, you need to look at, go back and look at your architecture again. Most of the time, majority of the time, the default auto data partition are the best way to solve a problem. Federated caching, a single cluster that's split across multiple geolocations, but also data sync from one node cluster to another. Those solutions also exist. So before actually looking into something like this, you should look into other architecture examples. Now, how do I achieve this? Is fairly straightforward. I start shard1 cache server with only one cache scheme defined, shard1 distributed. It's missing shard2 distributed cache service and this named cache, which is using this scheme. And not unsurprisingly, shard2 has a shard2 that uses shard2 distributed, and it does not have the shard1 distributed cache service defined. On the other hand, the test program that I run has both the caches, shard1 and shard2, because it's accessing both the caches. But I'm setting the local storage at the service level, not at the node level, and I'm setting as false so that my JUnit node that joins the cluster joins as a is stored as disabled node. And this is what we saw in this JConsole. So this is the way we achieve data sharding in Coherence. Now, the reason I wanted to show this, that it's how it is done, for first, a lot of many times the confusion is that it's the nodes when they join the cluster. In reality, it's not the node. Node is an abstraction here. It's the cache services that forms the cluster, not the node. If you have a node that does not define a cache service, that node will not participate in clustering for that cache service. On the other hand, another reason I wanted to show something. If you have watched my JDBC-ish driver for Oracle Coherence, you would have seen something like this URL. I made up a URL for my JDBC driver to connect to Oracle Coherence, something like this, which is very similar to any JDBC URL. Like if you download Oracle database, the default XC schema, your URL will look like JDBC :URL, Oracle, then thin username is missing, your host, your port number, and the schema name. On the other hand, I have JDBC co. I could have used Oracle. This is just a COH for Coherence. Username and password missing. This is my host, and this is my port number. Now, I deliberately in my implementation do not have a schema. Now, if you compare these URLs, this is the most critical piece which is different, and I wanted to demonstrate. When we create multiple database tables and we create relationship between them, aka joins, those joins are possible if those tables are within the same schema, right? On the other hand, in Coherence, there is no schema in this example, but if I have to give an implementation of a JDBC driver that could potentially support a true join implementation, I potentially could have given a service name. So let's say Shard1 cache configuration, I could have given this as my schema, right? What that would have meant? That means any database or caches I create using this schema would be served by this caching scheme. That means if the cache service is exactly the same for any number of caches, then there are multiple things that are possible. You can force co-location of the data, and if they can be co-located, you can force a transactional atomicity, changes to multiple entries residing across multiple caches in the same location, and you can force an atomic operation. Now, working with Oracle Coherence, I think there has been implementations of transactional caches, now EOL, and similar implementations that you might have come across that kind of try to replicate the database operations or database type of interaction with this data source. But ultimately, if you really need to have atomic operations or you need to implement joins, you need to make sure that the database tables, or in this case, data caches, are managed by the same scheme, similar to database tables managed by the same database schema. And that's the reason why it's called cache scheme, and that's the basic difference. So this is sometimes an overlooked information, and I wanted to show this as part of my this video series. I hope you enjoyed it. Thank you for watching.